Hello all, I'm Roger Killen and I've been asked to chair this afternoon's session. By way of background, I'm an electronic and control engineer by first degree, and I started out in the chemical and pharmaceutical industries with ICI. After a few years, I left ICI to do an MBA at Stanford Business School in California, and I've been entrepreneurial since then. In 2000, I entered the world of healthcare, where I co-founded a company called Dr. Foster. We produced the league tables of hospitals and became the #1 hospital benchmarking company in the UK. In 2005, after leaving Dr. Foster, I founded my own company, the Learning Clinic. We were famous for inventing mobile apps on iPod Touch for nurses to document patient observations at point of care, their blood pressure, pulse rate, respiratory rate, etc. In partnership with academia, we also led work on the creation of validated patient risk models from analysis of our patient data, including patient biochemistry, hematology, and physiology. The real-time application of these risk models in our applications led to huge falls in hospital mortality rates, infection rates, etc. And we published many papers and won many national awards for improving patient outcomes. I finally sold my stake in both these companies in 2015. In recent years, I've been investing in and working with healthcare startups. Alongside this work, I also worked part-time at the university from 2018 to earlier this year as Royal Society Entrepreneur in Residence, and that role gave me an opportunity to work with a number of Exeter University spin-outs. These experiences gave me a privileged insight into the quality of people and IP being developed here at the university, which I found impressive, thankfully. I'd like to briefly share a few examples of these spin-outs to demonstrate the variety of business approach and also the variety of journeys that these spin-outs have taken. I'm an investor and non-exec director of a spin-out company called Atomarker Limited. Atomarker owns patents in blood testing technology, where the early patents developed here at Exeter date back to 2008. Atomarker has been searching for scalable markets where the differentiated benefits of its testing approach are most compelling. Perhaps their time has come, as COVID has opened a real opportunity for their technology. We're currently part of Boris's Moonshot project, and if government testing of our devices at Porton Down goes well, then our machines could be rolled out nationally. We're in talks with a FTSE 100 company to support us in this rollout. Lessons for Atomarker include how it can take a long time to get technology accepted in healthcare, and also how important it is to be in the right place at the right time. Another company in which I've invested is Watercress Research Limited. It's a spin-out from the medical school here, looking at the medical and nutritional value of processed extracts of watercress. It's attracting a lot of interest from industry, where the active extracts of watercress look like great natural replacements for existing synthetically created compounds. Their products appeal to markets on the basis of a great story, more than the quality of their IP. It's a marketing and sales-led company, rather than a technology-led play. The final company I'd like to mention in this intro is Full Scale Dynamics Limited, which is a spin-out from the engineering department here. They have navigated a different commercialization journey in that they're a group of engineers who have successfully operated a consultancy company based on their internationally recognized expertise in vibration. They're now launching a product-based company based on their learned expertise and market reputation from the consulting. This transition from consultancy to product is a common route to successful business development and is often attractive to investors. We're now going to hear more detail on some good and varied stories of commercialization from within and associated with the university. Please do note any questions you have for any of our speakers and ask the speakers to address these at the end of the 3 talks. So first, I'd like to introduce John Love, who is Professor of Synthetic Biology here at the University of Exeter, which he joined as a lecturer in 2003. John has won a host of awards for innovation and for the impact of his research. Of particular interest today, he has successfully developed close collaborative partnerships with several businesses, ranging from local SMEs to multinational companies. He has a partnership program with Shell on biofuels research, which I'm sure he'll share with us now. Over to you, John.
Well, thank you very much, Roger, for that very kind introduction. Now, I've titled this talk U2B2U Innovation. This actually means university to business to university, because the way I see innovation working, and the best part of innovation is when there's this virtuous cycle between new ideas, development, and then improvement of these ideas. And if I could have the next slide. I'm going to talk today about two stories. The Shell story, which is a conventional academic business relationship, and the iGEM story, which is something that I've become very, very interested in. I want to share with people here at the university, because this is student-led rather than academic-led. And I believe that our students are a massive resource that we currently, if not undervalue, at least don't use to our full extent. So if I can have the next slide. Next slide, please. Okay, there seems to be a little problem there. No, that's good. Sorry. Okay, so essentially the story of Shell is that we are currently in a transition from the petrol economy, which is dependent on fossil biomass being fossilized and then dug up and mined to generate not just energy in the form of gasoline or diesel, but very, very important platform chemicals such as plastics, for instance. And so we're transitioning away from that fossil economy to a bioeconomy. And Shell are at the forefront, like a lot of big oil companies are, of this transition. And they aim to be carbon neutral by 2030 now. So that is the aim, and biofuels are a big part of that. And you can read more in the Shell Sky scenarios, which is their vision for the future. And if I can have the next slide. But really the most important thing, and one of the things I think that we've learned from the COVID epidemic as well, is that mobility of people, products, and resources is absolutely fundamental to our economic prosperity. If you can remember at the start in the spring when we had lockdown, many companies' supply chains just collapsed because we are very, very interconnected in the world. Unfortunately, 75% of all the fossil petroleum that we mine is used for liquid transport, and this causes massive effects on the environment. And it is very, accepted that decarbonization of this sector is absolutely fundamental to solve some of the climate crisis. And that can be achieved through electrification of cars, for example. I hope to show you that it can also be achieved through advanced biofuels, because not every vehicle can be electrified, and not every area of the world is capable of being electrified relatively quickly. And also the other aspect that we sometimes forget is the carbon offsetting, sequestration and storage. And we've got colleagues in geography who are currently working on that very intensively, also with Shell. May I have the next slide, please? So as Roger was saying, I started in Exeter in 2003, and almost immediately I began my interaction with Shell Biodomain, which was the business unit that was set up to explore the potential of microbial or third generation biofuels. And for the next decade, we systematically investigated all of the microbes that were oil producers, be they bacteria, fungi, or algae. And what was quite unique about our research is that we combined it with economic and process modeling, and also the business models that the MBAs at Shell were able to give us, in order to assess whether or not any of these systems may be amenable to large-scale application. But unfortunately, every single system failed that economic hurdle. And sometimes the oil yields were very, very high, approximately 80% of the dry cell mass. And what was the real killer was the fact that the paradigm, if you like, for fermentation or for oil production was basically as old as the hills. It was putting them in a vat. It was like brewing, essentially, and that's been going on for at least 3,000 years. And another aspect of that was that the product made was not actually the product that was required. It really necessitated a lot of post-harvest processing, which is essentially the same as refining. But remember, you're not getting barrels and barrels of microbial oils. You're just getting a lot less than you would normally from an oil well in the ground. So unfortunately, these biofuels were just incompatible with any sort of commercial activity. May I have the next slide, please? And so this led to a question that really scared me. And this was asked by the Shell senior scientist quite directly: are biofuels a stalled technology? He was very willing to accept that currently biofuels such as ethanol or biodiesel, they work as additives in engines, and they cannot be produced at sufficient volumes and at low enough costs. So all of the biofuel that is added to petrol fuel, if you like, biodiesel or ethanol, actually is sold at a loss. However, we do need these in order to decarbonize this economy. And one of the other problems as well was that essentially the technology of fermentation to make alcohol or ethanol is ancient and has not improved. And plant oils conversion to biodiesel has not changed in over 100 years. And in fact, we can see here from the quote by Rudolf Diesel that he was actually believing that soon plant oils would replace the fossil alkanes, so the fossil fuels, and that was in 1912. And it's been over 100 years and nothing yet has changed. So we need an absolute radical change in paradigm if we are going to be able to produce and burn fuel of this type. May I have the next slide, please? And so this was the paradigm shifting change that we introduced to Shell Biodomain. Bioalkanes are chemically identical to fossil fuels. Now, a bioalkane is essentially a wax product that is made by a living organism. And many living organisms make these waxy products. So the blue-green algae on the top left that you can see make them. Fungi, the pink mass just below the blue-green algae, also make them. Insects use them to impermeabilize their cuticles. Plants use them to impermeabilize their leaves. And various animals use them also as waterproofing for feathers or fur. But it is absolutely inconsistent to hope that we will be able to harvest sufficient fossil replica fuels from animals in this way, like this duck is doing here. So instead, we developed new synthetic biology ways in order to make those. And if I can have the next slide, this will diagram that process. So this is the process. Essentially what we did, we hijacked the internal fat metabolism of E. coli cells, so gut bacteria, and bolted onto those various synthetic biology modules in order to generate replica fossil fuels, but in a living organism. And so this was a proof of principle, and this proof of principle was patented in order to protect that investigation space. And once we had done that, the next killer question arose: how are we going to do this at volume, and how are we going to be able to market these products? So if I could have the next slide. So essentially, in order to do this, we had to have quite an interactive discussion with Shell Biodomain, where we had to insist that we needed a change in the fermentation paradigm. Currently, fermentation occurs in large, still in the ground style infrastructures that are quite capital expensive, and temperatures are controlled very tightly, and processing costs are huge. So what we decided to do was, look, let's just let the material just rot, but rot with the appropriate biocatalysts that can produce the fuel or the chemicals that we are seeking. And we have chosen two different biomass sources for this: sugar beet at the top and ensiled sweet sorghum at the bottom. And the role of ICURe now is to engineer the microbes that can thrive in these environments and rapidly degrade that biomass to the required product. At Shell, what they're doing is they're actually investigating all of the process engineering in order to purify the product subsequently, and all of the resource allocation to obtain the biomass and treat it. And this requires for them a massive culture change, in as much that oil refining is typically performed in large monolithic refineries. This form of biofuel production is more decentralized, and that is something that the business is actually not necessarily struggling with, but coming to realize that a change must happen, and this will radically change their business model. The advantage as well of synthetic biology is that we can relatively quickly reprogram the bacteria to produce chemicals that might be in demand, and therefore not just use the biomass to make fuel, but use the biomass to make things that are direct chemical replacements for the fossil petroleum. So if I could have the next slide. And this is just an example of our research map from our current research project. And you can see how these various aspects of bioscience, metabolomics, chassis selection, so microbiology, bioinformatics, and synthetic biology all interact together. And Shell Biodomain is actually core and central to that. So this is a very close partnership, which relies on them being able to give us enough commercial insight and into their imperatives, and us being able to give them the deliverables that they require, but in an honest and open way. If something is not possible, and there have been many ideas that we have investigated that have not been feasible, it's beholden to us to actually tell that to the company. May I have the next slide, please? And so this is essentially the Shell, the ICURe Shell Innovation Funnel as we currently practice it, based on a fail fast, fail cheap scenario. For Shell, it is actually important to know the failures as well as the successes. Our team, my team, needs to be quite agile, and it also needs to be delivery focused. So we're not able to wander off in some sort of esoteric academic manner. We have to remain focused on the problem at hand. We also are extremely networked within the industry and also within academia, which adds value to the program. And our role is very much horizon scanning and taking ideas from paper to a pilot, so technology readiness level 6. And Shell have estimated our value to them as about 100 million per year RNPV. Now, how does that work in practice? Well, within the university, we have a flexible framework agreement with Shell, which over the lifetime of the project, since about 2003, has brought in 1 million a year. And currently, and very slowly, we are gradually expanding our influence and our results into other Shell business units apart from Biodomain. So we're now looking into helping Shell with their production of renewable natural gas, looking at Shell Health to assess the economic impact of their installations, and nature-based solutions to investigate the best areas in the world for carbon sequestration. And obviously this variety of activities provides superb training opportunities for our students and my postdocs. So we have a number of undergraduate 2-a-year internships with Shell, which are funded at $69,000, so very, very blue chip in that regard. We have postgraduate studentships, both at master's and PhD level, and our postdocs can go on to do industry fellowships and link very closely with Shell in order to get this understanding of how best to integrate industrial imperatives into a practice for their own company. And if you can go to the next slide, please. And essentially, people are always asking me, well, how do you build such an open innovation partnership? Well, to be honest, I thought what I'd try and do here was to have on the left what Shell gave me, on the right what the university brought to the party. But when I thought about it more carefully, I found that actually everything in the middle is brought by both partners. When you enter into a partnership, you're entering into a human relationship with the people that you're working with. And I believe strongly that in order for something to succeed, we must have a cultural alignment with the company. So for example, Shell research wing that I have are very much research scientists that understand research. And I also then have to understand their side of the story from the business perspective, which is why I then went to do business, like the equivalent of an EMBA at Harvard this year. So we also must share our priorities. We need to have innovative ideas. I need to have the intellectual bravery to actually step up to the plate and say, you know, this might never work. Here are the parameters. And then I must run the risk of that project being defunded. But with the relationship that we have, because there are inevitably more ideas to investigate than time to investigate them, we are able to mutually create value. And essentially, what I'm asking Shell is to trust me and to respect my integrity in the same way that I respect theirs. I try to understand their context as they try to understand mine, and we mix up our knowledge in as dynamic a way as possible through staff exchanges. Obviously, this takes quite a different form of academic leadership, and it also takes a different kind of industrial leadership from Shell's perspective. So we have all invested time and effort into that, and through patient communication, I think we've been able to build this rather strong partnership. On the Shell side, what they bring exclusively, if you like, are their commercial and economic imperatives, and also a level of control seeding of their actual R&D program, which is a risk for them, but hopefully it's a good risk because we're together and working together. And also they must shift from a position of transaction to a relational partnership with us. On the university side, we have to overcome speciality bias, and you will typically see older academics very, very specialized with teams that are focused on just the one thing. But I have to be actually a much more generalist type of leader, leading a team of specialists. And I must give them clarity. I must make sure that they are agile. I try to make them as inclusive as possible. And one of the things that I find difficult at the university setting is to provide them with the recognition and the appropriate progression and training. But that is something that I'm working with Shell. So if we can carry on down to the next slide, I'm going to now tell you the second story that I wanted to discuss. Sorry, can I have the next slide, please? No, maybe not. Okay, yes, I can. Thank you. So this is iGEM. Now, iGEM is an international student competition that in synthetic biology, typically attended by about 350 teams every year. And if we can have the next slide, please. In Exeter, we've been working on iGEM since 2012, was when we started. So the students choose their own project. And as you can see, through the years, we have been able to progress to developing extremely good projects. And one of the ones that I want to talk to you today about in particular is PETX. So that was achieved just last year in 2019. Next slide, please. Yeah, next slide. Okay, so PETX, the student team were very dismayed to learn that approximately 35% of microplastic pollution in the ocean came from laundry. And so they came up with this brilliant little method in order to protect, so they devised a filter to degrade, to capture and degrade the microplastics released by laundry. And therefore they called this project PETX, so, but their tagline, protecting the oceans one wash at a time, I thought was amazing. And they won the gold medal for this, and they also won the award for best entrepreneurship, because we embedded entrepreneurship and industry relations into the project. And if I can show you the next slide. Thank you. This was their solution. They devised and prototyped a really nice filter, which collects and degrades using an enzyme that they also created in the lab to degrade this plastic. And you can see here two of our students working on that. And they interacted with a number of industry people at this point, the Microfiber Consortium, one of them, Ralph Lauren being another, and also Miele, who gave us the washing machine and a lot of engineering insight as to where we could position these filters in the machines. So on that basis, they also developed a business plan for a small startup. If I can show you the next slide, please. And this business plan, if you like, was devised by the students and earned them the Best Supporting Entrepreneurship Prize out of the 400 teams that attended that year. So if I may have the next slide. Unfortunately, that is roughly where the project ended. The students basically took the project to prototype and demonstrated that prototype. And now my role, my job, if you like, is to try and support them through this valley of death. In order to do that, the laboratory, the department, and the college all agreed a way in which we could work with the students. And our RKT and student entrepreneurs were very, very supportive of this. The students have done a number of startup competitions and have also directly appealed for venture capital and angel capital. And we have had a number of industry visitors, notably from Repsol and just yesterday from PAS, a German company who is interested in this. The students also just this week won the Champion of Champions 2020 at the Student in Business competition, a national competition. So this is a fantastic idea. But unfortunately, within the university, we're still trying to struggle to find the vehicles how we could support our students beyond initial ideas and development and take them that one step further. And so many people ask me, why do I even bother to do this? Because this is just, you know, this isn't really my day job, but it's a lot of fun. And if I could just have the last slide, I'll try and explain to you why. So when I was doing my EMBA at Harvard, we had a module on authentic leadership where we had to drill down into our own selves and try and work out what it was, why we got up in the morning. And essentially, I realized at that point that my aim is to open the opportunity for, if you like, for Shell to produce biofuels cheaply in order to save the the environmental crisis, and for my students to be able to develop their own ideas. And I think that, if you like, the way I think of industry interaction, it's not necessarily what you do, it's sort of who you are. If you want to see your ideas come to fruition and actually make a difference to the world, then I believe that industry interaction, is an extremely good way to go. And I'll just stop there, and I'm sorry I've overrun, and I do apologize to the organizers for that.
Well, thank you very much, John, for that talk. And I'd be quite interested to meet the iGEM people. Sounds fascinating. And a relationship that's managed for 17 years and still going. Well done. What I'd like to do now is introduce Lorna Harries, who's Professor of Molecular Genetics at the University of Exeter Medical School, where she heads the RNA-mediated mechanisms of disease group. Lorna will offer her perspective on the ICURe process and her experience spinning out Senisca, a company developing new approaches to reverse cellular senescence, where she is founder and chief scientific officer. Lorna will offer insights and important considerations for academics when they're seeking to commercialize their research effectively. Over to you, Lorna.
Hi, and thank you for that, Roger. So yes, so I'm a brand new entrepreneur. So as Roger said, I'm now founder, director and CSO of Senisca, but I am also Professor of Molecular Genetics here at the university. And we're really, really early in our commercial journey. And ICURe actually has been pivotal in helping us to take those baby steps in this space. So I'm going to tell you about our journey and how we got where we are at the moment. Can you see those slides okay? Great. So this is where it starts. So this was an unexpected finding. So I lead an RNA biology group. We're interested in the nuts and bolts of the big black box between DNA and protein and how genes are switched on and off. And back in 2015, I had a new postdoc, and to help her sort of cut her teeth in the lab, I gave her a little project, a little side project unrelated to what she was meant to be doing, to teach her our way of doing things. So I gave her a bag of chemicals that I thought might or might not have an impact on the expression of a pattern of a profile of genes that I was interested in, and said, go and have a look. And off she went, and she did. And yes, it did have an impact on the genes that we were looking at. But actually, more importantly, we found that these chemicals, through the action on these genes, was able to actually turn back the aging clock in cells, which was something of a surprise and something that we absolutely were not looking for. But nevertheless, that's what we found. So yeah, we didn't really know what to do with this at that stage. I run a basic science group. We hadn't really thought about commercialization or the potential for that within the team. But we published the paper and went on our happy way. And the day after that paper came out, I came in on a Monday morning and we had 6 or 7 emails from people effectively offering to help us take this forward in a commercial setting. And I had absolutely no idea what to do with that. So things I didn't know at that stage was how to sell this work to a different audience. This isn't an academic endeavour, actually. And how investors work, I saw it as a ticket to a big grant that could help me take this work forward. What to tell investors and what not to tell them, actually, crucially, which is probably more important. And what the path to investment usually looks like. So I had this crazy idea that we'd shake hands, it'd all be very happy, a big check would land in my account at the university, and off I would go with this. But that's actually not what happens. And how long discussions take. So that slide that Tori put up this morning really rang bells with me. I thought it would be a lot quicker. And how commercial research differs from academic research, it's a completely different animal. And what we needed to have in place in order to protect our discovery. And that's a picture of the Mayfair Hotel that Tori and I got taken off for lunch at by one of these prospective investors. This is the same group of investors who were talking about where they might be able to land their helicopter when they came to visit. So this tells you a little bit about the difference in how people view these things and the sorts of circles that people move in. Luckily for us, there is support in the form of our excellent IIB team. And at this point, I'd really love to give a big shout out to Tori, who has held our hand all the way through this with grace and patience, because I'm pretty sure I've tried her patience on a number of occasions. But IIB are a really, really useful source of resources for and information for people who are hoping to commercialise their research. So they offer mentoring in the commercial space. I had no idea what I was doing when I started this. IP advice, as we've heard a little bit this morning, how to go about protecting your innovations. Things like patent applications. Anyone that's ever read a patent, it doesn't read like any research paper or any piece of writing that you've ever read before. It is completely different. Also help with contacts and introductions, things like the Medicines Discovery Catapult and Set Squared that we heard about this morning. There's actually financial help in the form of a pre-incorporation budget that can help you with things like bringing in experts, contacts, bankrolling some of those, those essential meetings and things that you need to have, and much, much more. There's lots of information on their web pages, which I'm going to let you go and find on your own. But one of the things that we got pointed at through IIB was ICURe. And now ICURe is an Innovate UK funded programme of commercialisation support for teams of academics who want to explore the commercial potential of their research. And I cannot recommend it highly enough. It was really useful for us. This is the basic process. So you start off with an application. That goes, it's a competitive process. You put your application in, and actually pretty quickly for a grant application or an application of this type, you get a decision as to whether or not you've been accepted onto the ICURe programme. And if you're lucky enough to be accepted, you get an invitation to this thing called boot camp. And it is called boot camp for a reason. It is really hard work. And then this is a team endeavour. This isn't just about you as an academic, it is about you and a team of people, which I'll come to in a moment. Now, your team will consist of you as the scientific lead and an entrepreneurial lead, which will probably be one of your early career researchers, a business advisor and a tech transfer officer from the university. Now, excuse me, it's your ECR that actually goes on the journey. It's your ECR that learns from this, and you are there to support and to provide the scientific backbone for that. But your ECR will be mentored and upskilled rapidly in the commercial space and what that actually means. So your ECR will go off on a journey, and I'll tell you about that in a moment. And then this ends up in an options roundabout, which basically is a kind of go, no-go point for sort of taking things forward. If you get through that, you get some follow-on support to break a business plan, etc. I'm just going to take you through each of these steps in a little bit more detail. So the ICURe application, for those of us who are used to writing academic grant applications, it's actually surprisingly light touch, which was really, really nice. But some of the things that we need to think about for this application, you need to crystallise your idea. So us academics like to think about things from all perspectives. We like to kind of go down rabbit holes from time to time. But what you need to do for this, commercial research is very different. You need to figure out what is the most tractable commercial application of your idea. And it isn't academic research, and this is really crucial. What you need to know in a commercial setting is very different from what you'll need to know in an academic setting. You also need to choose your team. You do this as part of a team. So you need to know what skills do you need on that team, who's got those skills. And as I say, you need a science lead, an entrepreneurial lead, a business lead, and a tech transfer officer. So here you need to think about who you can work with. So these are people that you're going to get very close to and you're going to be spending a lot of time with. So you need to make sure that it all gels very nicely and it's all very nice and synergistic, and that everybody has a role and everybody understands their role. So again, this is, as I say, that understanding of your role is really important. So this is to upskill an ECR to take a commercial role. It's not you. You may well be walking that commercial path with them, but ICURe is specifically about your ECR. And things you need to think about before you do this and before you put your application in are what stage of development your tech is at. What TR stage are you at? And who will use this? It's no use having the most incredible innovation in the whole world if no one is actually ever going to be interested in it. What's your competitive advantage? What are you doing that your competition is not doing? And what information do you need to actually help you get where you want to be? So you put your application in, and if you're lucky enough, you get an invite to bootcamp. So bootcamp's over 2 days for us. It's actually 3 days for the ECRs, and it is full on. These are days where you're starting at 8 and sometimes you're not finishing until 10:30. We were all exhausted. In the photo you can see on the other side of the slide there, these are the ICURe team, and they're all in the bar. We at this stage were not in the bar. We were still working on our business model canvas. So they all had a wonderful time. So things that you'll get from bootcamp are some mentoring in, how to cold call a company that might have information you need, how to work a trade show, how to get the most out of it, how to get your ideas across quickly in business speak. This is not something that comes naturally to me. I'm sure it doesn't to other academics. And importantly, who are you and what are you selling? So your vision for your tech, your virtual business card, the ability to get the idea across in a really quick, succinct manner that people are going to stop and listen to. People are not going to listen to you doing a 15-minute ramble on how wonderful your idea is. They want to know what it is, who you are, what you're selling. Identifying your market segments. So who are you targeting? And to finalise your action plan and your budget. So where is your ECR going to go? Who are they going to talk to? What are they going to do? And how long are they going to go for? And you have to finalise this at this point at the end of day 2, which is one of the reasons why bootcamp it's so full on and very intense and has those long days. Okay, so your ECR goes off on a journey, and this can be, in our case, it was an actual journey. At the moment, it may well be a virtual journey, but your ECR needs to have 100 meaningful conversations, and by meaningful, I mean they have to come back with contacts. They have to come back with some idea of market research or advice, or have arranged meetings with potential endpoint users or customers or partners, and also use the opportunity to scope out competition. And these are 2 postcards that Ben, our ECR, very kindly sent us to show. And he was really lucky. He actually did manage to get to do some travelling. So this was Ben's ICURe journey. So he started off by going over to the States, both coasts, and talked to anybody who might be interested in a cell rejuvenation technology. And we identified during ICURe that there were several potential spaces, including pharmaceutical. That was the first one I thought of, but also cosmetics and cosmeceutical. There's a lot of people out there who are quite actually vested in the idea of looking and acting young. The agri-tech sector, which is something I really hadn't thought about, but this was apparently a lot of crop yields are dependent on the process that our tech targets, and also veterinary. So as you can see from the list of different people that Ben talked to, it's from a wide range of sectors. And he actually had 92 meaningful conversations before COVID got in the way, and he was confined back to Exeter. But he talked to 68 companies, he made 5 potential collaborations, he talked to 4 regulatory bodies, and actually 15 investors. So he did a really good job of this, and it gave us a really good head start. So we distilled all of that down, he made a pitch, and we went to the options roundabout. So at the options roundabout, your ECR will effectively do a 10-minute pitch, as you would to, in the corporate setting, as you would to an potential industrial investor. And that pitch basically sets the scene for your market, for what you're wanting to do, who you're targeting, what your competitive advantage is, and all of that. And at the end of the options roundabout, you can basically be recommended 4 ways forward. So the team can go forward and say, actually, this isn't ready, you need to go away and do more research. Or they can recommend perhaps that you might want to license your tech to an external party who would then give you royalty revenues. They may recommend some sort of commercial collaboration or co-development deal, which you'd work with somebody else to develop the idea, or they may recommend that you spin out. And if they recommend that you spin out, that then opens doors to more money and more opportunities. So they give you an opportunity to have another 3-month salary for your ECR to develop a business plan and to start to explore a little bit more in this space. They give you business planning advice, and also importantly, the opportunity to apply for a pot of ring-fenced money from Innovate UK, which is specifically for ICURe graduates. So it gives you a little bit of non-diluting funding for the company that you will eventually eventually spin out. This is funding that comes into the company that you do not have to give away equity to get. So we were lucky. Our options roundabout outcome was that we spin our company out. And this did open some doors for us. So it gave us, as I say, an additional 3-month salary extension for Ben. And in that month, those 3 months, Ben used month 1 to kind of develop a business plan, prepare the application for ICURe. They give you very tight turnarounds on these things, so it's really got to be really carefully thought out and down to the wire. And it's a different sort of application to the sorts of applications that your typical academic may be used to writing. Also for month 2, to sort of look to find a suitable investor, you have to match fund these. So the Innovate UK ICURe Ring of Fence money comes with a 30% match funding requirement. So you need to figure out who's going to supply that match funding and what they're going to want in turn for it. And also to finalise your investment documentation. And then to apply for the ICURe Innovate follow-on funding, which is up to 300k, and that comprises the Innovate UK investment, but also the investor match funding. Okay, so just as a bit of a reality check, I'm going to tell you a little bit about our timescale so that you can see what this actually entails in real life. So this is our interesting result here that I told you about, this discovery that we could turn back the aging clock in cells. And we had really high hopes for this, and I had anticipated that we'd have this all sewn up actually probably by the end of 2016, which is not what happened at all. So the paper came out in 2017. Like any disruptive technology, any paradigm shift in the way people think about things, it took us a long time to get this published and through peer review, but we got there. And we had these approaches from these investors pretty early on, as I say, literally the next working day after this paper dropped, we had these investors kind of knocking on the door, which was really nice. At which point I contacted IIB pretty quickly because it became very apparent to me very quickly that I had no idea what I was doing. So with help from Tori, we managed to kind of carry on with the research and actually file a patent on our tech, which is actually a platform that we can use to adapt for all sorts of different things. And we carried on the research with further papers, again, always making sure that we had our IP in place. And then in December 2019, there was one investor that we were going forward with, and these guys signed an intent to invest with us. It came with a no shop, so we were not allowed to talk to any other investors, and they were promising £5 million for us. So I was really pretty happy at this point in time. It was all going wonderfully. We were working with a partner at another university, and there were delays and more delays and more delays. In fact, there were about 6 months worth of delays. This was very frustrating, you know, for someone like me. I don't have much patience at the best of times, but 6 months delay here, I couldn't understand why everything was taking so long. And unfortunately for us, in that 6 months, our investor had an investment to themselves of about, I think, £30 billion, which came with strings. And those strings were that they could not fund anything that was not going to be in phase 2B within 3 years, and we weren't because we're early. So they pulled the plug. And as I was saying, you know, it's a real roller coaster. And at that point, I think I was kind of this close to saying, right, that's it, I've had enough of this. But, you know, we're used to no in the academic world. So I went back to the other investors that we'd been approached by. And at that point, we decided to go for ICURe. That happened in 2019. The funding was approved in 2019 in November. We went to boot camp in January 2020 and then went off travelling just after that. And then, of course, COVID hit at the end of March. So luckily, we'd just about finished at that point. And we went to the options roundabout in March. We had our follow-on funding in April. And we submitted one grant within that ring fence grant in May, which unfortunately missed out on funding by a whisker, but we were given the opportunity to resubmit. So while we were preparing that resubmission, obviously we've got 2 or 3 investors now that who are interested in working with us, and we're really quite far along in diligence. So they're checking all the science, they're checking all our business plans, and the team is really important. Actually, I think the team is probably more important to a lot of investors than the actual science, because that has got to work. And literally last week, earlier this week, actually on Tuesday, we put in our resubmission of that Innovate UK bid. And here we are now. So our company is Senisca, and we are just about to press the button on go. We've had all of the approvals from the university now to spin out. This is our team. There's myself as CSO, so I'm responsible for the R&D direction, and Ben, who was my ECR, who's now our chief technical officer. He's responsible for making sure that those ideas actually work and are not completely madcap. So he's the man that's actually going to make it happen. And we also have Kirsty, who's our chief operating officer. So she's coming with a wealth of corporate experience, and she has been amazing. So the IRB team actually put us in touch with Kirsty. So this is another case where the support that they can offer is really useful. We've also got some advisory, so we're actually going to be looking at oligonucleotide biologics. This is a particular modality which is really up and coming. So I'm lucky enough to have on our scientific advisory board someone who actually guided the very first oligotherapy through the FDA approval and the regulatory approvals in the context of Duchenne muscular dystrophy. And also Melanie Thomas, who's working on the same sort of therapies in the lung. So one of our indications we're thinking of going for is lung. So what have I learned from this process? Well, an awful lot. I've learned that it's not an academic endeavour. It's a completely different role with a completely different skill set, and that it's not going to happen overnight. So spinning out takes time. It's a long journey. You need to be resilient. There's a lot of challenges, a lot of waiting around, a lot of things that you're going to need to deal with. It's really stressful. And you need to be prepared to work really hard at all hours, whatever else is going on. So obviously I'm continuing to manage my academic team. I'm also deputy chair of one of the research council panels, and that's happening now as well. And we've also got investment conversations happening with West Coast investors at stupid times of day. So you need to be prepared to throw your all at it. And investors can be fickle, and they have their own agenda and their own challenges. But it's a really rewarding thing to do, in my view, and it's a viable way to translate your research to the real world, to turn it from a PDF in somebody's folder into something which is tangible and going to do some good. So just the final slide now, really my advice for what it's worth: spot your opportunities. There is commercial potential in the most unlikely places. If somebody had said to me years ago that I would have found something that had the slightest bit of commercial potential, I would have laughed. I wouldn't have thought there was anything that we could be doing in this space that that I would ever have found a marketable opportunity in, but there was. And decide what you want from it. So to examine your motivations. Why are you doing this? It's hard work. It's not an easy way to get rich. That wasn't why I did it. I don't think anybody that really goes into this with their eyes open, this is what they do. Protect your ideas, as Tori said earlier, to actually get your IP in place before you publish. It's really hard to actually put that in place later. One of the problems we had with our initial endeavour was our partners from another university had not patented the compounds they were using. So it's really hard to persuade somebody to put a bunch of money into something if there's no intellectual property protection. To choose your team really carefully. It's not just a check. Your team carefully. You've got to work with them, and they've got to work with you through times which are sometimes incredibly stressful. And to choose your investors carefully. It's not just a check. Your investors will have a seat on your board. They will contribute to the decisions that your company are making. And there is support, so use it. So make sure that you take advantage of all of the opportunities, the contacts that the university and the IIB team can actually offer you. And this is us. So that's the front page of our website. I wish I'd come up with that tagline. I didn't, but it's I think a really good one. And those are actually some cells from my lab. And as I say, I'm really happy to talk to anybody that's thinking about embarking on this journey. It's a roller coaster. It's a challenge. And I think if anyone's thinking about it, I'm really happy to talk to them about it, either here or outside of this arena. And I'll finish there.
Thank you very much, Lorna.
I'll just stop sharing my slides. There we go.
And I can certainly echo the value of ICURe, because I've acted as business advisor on a couple of ICURes, and it's a great process, and it can be a really good way to early stage money. So echo that strongly. I'd like to finally introduce Ian Bamsey, who's the managing director of Certus Technology Associates, who are an Exeter-based software and data analysis company. Certus has had a number of academic collaborations, including ongoing work with the LSI on using machine learning to determine effective treatments for patients with Duchenne muscular dystrophy. Ian will share an industry perspective on how academia and industry can collaborate successfully. So over to you, Ian.
Hi, hello. Okay, so as I've been introduced, I'm Ian Bamsey. I'm the managing director at Certus Technology. We're a local company, although we do have an office also in Sheffield. And I've been invited along to give you a little bit of a perspective from a company who collaborates with academia. I'm going to start off by just giving you a bit of background about who we are. I'm then going to tell you about what we do. I'm going to tell you about why we collaborate with academia, with all sorts of people, but in particular with academia. And I'm going to tell you a little bit about what we can bring to what's our side of the bargain when we collaborate. So let me kick off with a little bit of history. This is a very different story from the ones you've been hearing today, where people have been following very sort of commercial, conventional lines of business startups. Our business started with a kayaking expedition to Iceland in the late 80s. So the slide you can see there is my technical director, Rob. Rob and I organised an expedition, and I did that during my final year at university. And that was pretty good preparation actually for running a business, trying to do your finals and run an expedition simultaneously. 10 years after the expedition, after we'd both been off working in industry, working for consultancies, we got together and we started a business. And we started a business for all the wrong reasons. We started a business because we wanted a challenge. We didn't really have a product. We knew that we could write software because that's what we did. And we went out looking for business. And what we did was we came across people in the life sciences and in healthcare, and we found that we could work with these people very well, and we started building up our business. Next slide, please. Can I have the next slide, please? Thank you very much. So what do we do? So we offer software development and software services to a big range of customers. We partner very closely with our customers to help them achieve whatever it is that they're trying to achieve. We don't just package up a product and sell it to them. Just to give you a spectrum of the products, we have a administrative system for people who work in quality assurance in path labs throughout the country. So they're people who are in charge of ensuring quality in laboratories. We have a scenario-based training system, which is a rather innovative system that creates random scenarios which are real and that people can work through. We have a system for electronic lab notes. We have a database for patient records for building longitudinal studies and patient registries. And one that's not shown on this slide, we also have a data analysis platform. And those are the things that we package up into what we call our core technologies. And you can see as some of our business partners are shown on here, and you can see that there's a range of people from university through to NHS trusts, charities, and right through to pharmaceuticals. So we do quite a lot, really. I think we're quite broad-based. So could I have the next slide, please? So I'm just going to tell you a bit about why we collaborate. There we go. So back to Iceland again, why do we collaborate? Well, what we need to do is we need to find out what's coming up next. If you're rushing down a river that no one's ever been down before, you really do want to think about what's coming up. And that's what we do in our business. We collaborate to try to get an advantage. We need a competitive advantage. We need to be very different from just a standard web-based company that might be offering, your websites, etc. We need to be out in front and differentiate what we do. We need to look at what we're doing now, so what we're selling right today. We need to think about what we're going to be doing next, and then we need to look right beyond into the future, because we need to be building up our skills base and our capacity for what we perceive to be coming up. And the way I look at this is that we need to get lucky, and the way I define that is to do with luck being the preparation, meeting opportunity. If we're well prepared, when the opportunities arise, we can capitalize on them and we can move in. So that's really what we're doing, and we can do this by collaborating. We can find people who are working in similar areas, find out what they're doing, tell them about what we're doing, and then we can spark off each other. We can get involved in all sorts of different activities, and that will give us an overall advantage. You know, we increase our credibility through our partnerships, and we broaden our networks as well. And this is really why we go out and do this. So let's talk about how we collaborate. Can we have the next slide, please? So there are a wide range of ways that we can do this. I mean, at one level, we've been involved in 5 European projects with must be 25 European partners over the years in the big FP frameworks with Europe, which sadly are a little bit less common now, but that's one indication of the way that we can do this. And it can range from very informal engagements where, you know, we're pretty much just talking to people on a regular basis, finding out what they're doing and surveying the horizon, as I said, and looking for new opportunities. It could be that we enter into joint projects, we apply for funding with universities, and often, you know, you'll find funding calls where people are looking for industrial collaborators because obviously a lot of funding agents make that a stipulation of their funding, you know, so looking for small agreements, small businesses to work with. There are sort of other mechanisms like the KTPs, knowledge transfer partnerships. We can also operate in joint ventures. I think there's just so many different ways that one can collaborate. And I think that there are many formal mechanisms for doing this, but underlying this is really just about engaging with people on an ongoing basis. From my perspective, the more of that I can do, the more opportunities I can create. Some of those will go forwards and some of them won't. But in general, I think the muscular dystrophy was mentioned earlier. We first got involved in that by collaborating with somebody in about 2003. So, and now that's one of our biggest areas. So we work heavily in neuromuscular. So those collaborations have really opened out for us. Okay, so finally, just going to tell you a little about what we bring. So if I could have the next slide, please. Why would you want to work with us? Why would you want to collaborate with us? Well, we've been in this game for 20 years now. Unbelievably, it doesn't seem like that, but we have actually been in this for 20 years. We are, I think, quite innovative. We've had a paper published in Nature. We won an award through the Royal College of Pathologists for one of our systems that was deployed into blood transfusion training. We've got a wide network. We work with lots of people in lots of very interesting areas, and we can draw on those networks. We've got some domain knowledge. We know about some of the areas we work in, and we've also know a lot about what we do in terms of software and information systems. We have access to data, so we can go and talk to our partners and say, hey, how about we look at some of this data? I mean, there's formal processes involved there, but we manage that data. We manage some very large data sets of live patient data, and you know, we obviously can work through our partners and perhaps get access to work with that. I think another one which is very important, and people have talked about today, I've heard people talking about the difficulties of actually running and setting up a business. We're an operational business. We have some maturity in this. You know, we've been doing it for 20 years. You know, we can actually send invoices to people. We know how to operate. We know how to avoid the big mistakes. And that means that if we partner with people in a project, you know, we're stable and mature, and we can do something there. And I think people shouldn't underestimate the value of having a partner with those sorts of, with that as a platform to operate on. Okay, so just in summary then, I've told you a little about where we came from. It's not a conventional way of starting a business, but that's the one we did. I've told you where we came from, and I've told you about what we do, who we work for, and I've told you a bit about how we can collaborate and about why we can collaborate, and from my perspective, and that's, you know, explaining about that, the idea of we can get lucky, we can gain a competitive advantage by working with a broad range of people. And I've told you a little bit about the way that we can do that, and also the sorts of things we can bring. And I'll keep it that short. So please, you know, if you've got some questions, let me know.
Thank you for that, Ian. And having participated in my own businesses in collaborations with academia, I certainly found it was a very valuable part of our differentiation were those collaborations, in fact. So I've got some questions that are starting to come through. First one I'd like to address to Lorna, please. Did the initial paper that your postdoc published, I guess back in 2016 and 17, make it more difficult with IP later on?
That's kind of a yes and a no. So it didn't with the IP that we've actually gotten taken forward, because the initial paper was kind of an observation of first time this had been seen. We didn't have any idea how it all worked, and the subsequent papers kind of unpicked that, and we had the IP in place before that. That said, if our academic collaborators had seen fit to patent the small molecules we used as tool compounds, then this might have all happened a little bit earlier, but they would have been their compounds and not ours. So I don't think it was a barrier.
Okay. Thank you. Thank you for that. Next question I've got is, what is the most important characteristic, do you think, and this is addressed to, I think, all of you from your different perspectives, what is the most important characteristic which facilitates industry engagement? What would you say is the most important? What comes first to make things work? Ian.
From my perspective, I think an open mind, somebody who is inquisitive. So first approaches, in my experience, often just don't go anywhere. Somebody says, "Oh, you know, would you be interested in this? What do you think about that?" And the answer often is not really very interested. But if you keep an open mind and keep exploring and talking, it's funny how something comes out of it. And very often it's something that's just completely left field. Some of my best collaborations are with a PI who's now up in Newcastle, and it starts off by, you know, would you be able to do this? Would that be interested? And then it's ended up working in an EU project on something completely different, because there's some common thread or some experience which turns out to be key. So I think an open mind and an inquisitive nature.
I'd agree with that, actually. I've got that comment, so that's one of the comments that I thought. The other one that I think you need actually is resilience. And I think actually as an academic, we're quite good at that, because we're quite used to grant panels telling us, no, we won't give you any money, and reviewers telling you, no, we hate your papers. So, you know, I think that's something you do need, because it's a long and bumpy road.
Thank you. A question I'd like to address at John was, you gave two interesting sort of comparative case studies, the relationship with Shell, which is a massive multinational and long-term relationship. And then you went on to talk about the iGEM and in particular the progress of the company that you were referring to. Those are two very different scales of commercial activity. What do you think both of them have in common, and what don't they have in common?
I think actually they both have in common the fact that they will add value to the value chain, if you like. They will add value. We will add value to Shell. We will ensure through either it be carbon sequestration or direct biofuels, or the fact that Shell have to monitor the environment after their installations are decommissioned. All of that has to come together. So we add value there. We will also, the PETEX will add value to Miele. If Miele decide to put a filter like that in, if Novozymes decide to manufacture the enzymes, or Unilever or anybody like that, you know, that will add value. But it will also add value to the planet. And for me, that's actually really, really important. It's coming at it in a sense from this sort of idealistic sense, the feeling of why did I become a bioscientist? I didn't really become a bioscientist to mark essays or to push paper from one side of the desk to another, or really even to write grant proposals. I became a bioscientist because I love the natural world and I want to protect that. And I think that in this way, I find an outlet whereby I can do that, and it aligns with my inner need, if you like, and I feel that it's what you can see with anybody else here, Lorna, and you know, it aligns with what she does, right, and it aligns with who she is, and that's why I was thinking that while it's quite difficult to be both an academic and working with industry, because the university systems aren't necessarily set up to help you, by doing it, you actually become a more authentic person.
So a general question to anyone who wants to address it. What do you enjoy the most about the business academic collaborations that you're involved in?
So I think actually my answer to that question touches very much on what John has just said. So it's the opportunity to see these empirical advances that we're making within my academic group actually make a difference in the real world. I mean, how many people can say that something that they found actually may end up as a new treatment in clinic? That's what I want. That's where we're going.
Mm-hmm. Yeah. And well, I sort of agree with that. I think that, you know, as you do work in a university, you know, the thing that keeps me young in the university is the students and the actual ideas, right? And working with industry enables you to explore ideas you've never thought about. Like Lorna was saying, everything that she had to do in order to square that circle and attract those investors was not something we were ever trained to do. It was something we just did. And likewise, going to Iceland maybe and then just deciding to set up a company and roller coaster it for the next few years, why not? And we are lucky because we can do that from a relative position of safety, in as much that my job is not contingent upon the success of a company. You know, so I guess we get best of both worlds, really.
I think that's a very good point. And in fact, the only reason that we were able to set up our business was that having worked in, I mean, I worked abroad for 4 years, and it gave me a bit of cash. And to answer the question directly about, you know, what we enjoy, I mean, somebody once said that business, that there's two main things in business: cash and people. So you need the cash to be able to keep going. Yeah. But what you really need is great people. And what I really enjoy about collaborating is when we find the right people, when we find really great people, the things that come out of that are just so rewarding. You know, when we can work together and spark off each other and come up with something really different and really exciting, then, you know, you can actually go home and you feel pretty good about it, as opposed to going home and thinking about the cash, which is always depressing.
I've got a question here for Roger. What are the key requirements of an entrepreneur in residence? So what I'd say is where I felt I could add the most, but I think this is quite a personal question because there's not a specific role for what an EIR is. But from my own point of view, where I felt I added the most value when I was in role was helping that transition for the academic who's in researching. It's a very sort of inward looking study, whereas selling to the market is a very external facing feature, and helping them make that switch and that turn and understanding how those different audiences, what was the language of those different audiences. In particular, I knew the language of the markets. What was the speed and pace required? What were the energy levels required? What were the expectations about timings and the way that people report to you? And also to try and give the teams, the academic teams, the confidence to be able to speak to those audiences, because one of the things that those audiences love is confidence itself. And so I actually think giving that boost and underpinning them in some of those early meetings so that they actually, I mean, I wouldn't take them to the meetings if I didn't know they had the quality. So they all had the quality. But those who actually found that sort of inner self-confidence and communicated it well, that was a transforming as well. So often it was hand-holding, it was confidence boosting, and it was translating to new audiences, I'd say, were a number of my things. And also introductions to to commercial partners and funding partners. So are there any more questions? Does anyone else want to raise any questions amongst the panelists, or shall I think maybe we'll wind it up there, and I'll pass over to Krasi, and perhaps Krasi could wrap up today's event for us.
Thank you very much, Roger, and thank you everyone, really. I just couldn't agree more, and I really want to kind of reiterate what Ian and Lorna and John just said in terms of having and training researchers to be more entrepreneurial and to have this confidence that Roger was talking about. That was one of the main reasons we had when we thought of organizing an event like this, and we are hoping that we will be able to organize future events. So I'm really very, very grateful to the speakers for their fantastic talks, the energy and the enthusiasm that they brought to the event, and I am really looking forward to future events. So just once again, thank you all for your contribution to this event, all the speakers and all the session chairs. I also again would like to thank the industry team of the Wellcome ISSF 3 Center. Jihangir, Jack and Matt have been instrumental for bringing and putting this event together. I also would like to thank very much Lisa and Ross, as well as the research event team, for arranging the team's live event. And finally, I'd like to make an announcement about a strategic partnership agreement between the University of Exeter and the Medical Discovery Catapult that you have heard about, I believe, from IIB. It's an Innovate UK-based research technology organization, and the agreement that has been signed very recently basically has a starting date of today. The broad aim of this partnership is to enable collaborative research, translational activities, knowledge transfer, and people exchanges between the two institutions, and also to identify funding opportunities to sustain translational research at Exeter. So I'm really looking forward to these activities growing and expanding and engaging researchers in this type of activities. So to start with, we will be launching an industrial seed corn funding round that will open imminently for projects in collaboration with the Medical Discovery Catapult. There will be also opportunity for internships for students and potentially postdoctoral fellows in the future to spend some time at the Medical Discovery Catapult and to work on projects of mutual interest between the Catapult research department and our researchers and academics at Exeter. So with that, again, thanks again. I really enjoyed all the talks. I hope you enjoyed as well. And I'm looking forward to seeing you all in the future. Thank you very much.